friends. Today we will like to present our assignment. The title is Medical Safety. Our subject name and code is BEEZ4823 Medical Devices and Instrumentation. Year of class is 2023. Let's meet our group members. My name is Nur Nasrin Shazwani binti Haznan, metric number B0820100185. Next is Nurul Afifah binti Alias, metric number B0820102225, and Azra binti Azharuddin, metric number B0820102270. Next, our group member's name is Nur Amira binti Abdul Hamid, metric number B08201093, and lastly is Nur Shakina binti Shaharuddin, metric number B0820100054. Further explanation about medical safety, we will use sound animation to represent us as presenter.
Introduction. Hi, I'm Nasrian. I will present about what is medical safety. Medical safety refers to the practices, processes, and regulations implemented to ensure the safe design, manufacturing, use, and maintenance of these devices in order to minimize risks and prevent harm to patients, healthcare professionals, and the healthcare environment. This is a summary for each subtopic in this chapter. Firstly is electrical safety. Electrical safety is essential in the field of medical devices and instrumentation. Medical devices rely on electricity to function properly, and ensuring their electrical safety is crucial to prevent harm to patients, healthcare professionals, and others involved in their use. Secondly is radiation safety. Radiation safety in medical devices is crucial to protect patients, healthcare professionals, and others from potential harm caused by exposure to ionizing radiation. Examples of medical technologies that use radiation, like X-ray machines, CT scanners, and nuclear medicine equipment, are carefully regulated to ensure strict safety measures. Thirdly is chemical safety. Chemical safety is vital in medical equipment to protect the health of individuals, including patients, healthcare professionals, and others. While medical devices may not typically contain chemicals, certain elements or materials like adhesives, coatings, or sterilization agents can pose a risk due to their chemical makeup. Fourthly, biological safety. Biological safety in medical devices is crucial to protect patients, healthcare professionals, and others from potential risks associated with exposure to biological agents. Medical devices that come into contact with patients or biological materials, such as surgical instruments, implants, or diagnostic equipment, must prioritize biological safety. Next, let's move to fire and explosive safety. To protect patients, healthcare professionals, and the environment around the hospital from fire and explosion dangers, fire and explosive safety is an essential part of medical safety. Last but not least, environmental safety. Environmental safety in the context of medical safety refers to measures taken to protect the environment from potential hazards associated with the use, disposal and management of medical devices and related activities in healthcare settings. Thank you, Nasrian. Hi, I'm Azra. I will present about electrical safety in medical devices and instrumentation. Here are some key considerations and steps taken to address electrical safety. Firstly, electrical standards and regulations. Specific electrical safety requirements and standards, such as the IEC 60601 series, must be followed by medical devices. These standards outline the specifications for grounding, leakage current limits, and other electrical safety features. Secondly, insulation and grounding. Medical devices should be built with proper insulation. Thirdly, leakage current. Medical devices should meet specific limits for leakage current, which is the unintended flow of current through unintended paths. Excessive leakage current can cause electric shocks or harm to patients. Fourth, isolation. The risk of electric shock is reduced through isolation, which ensures that safely the patient is not in direct contact with any potentially dangerous electrical components. Fifth, electrical safety testing. Devices must be tested to ensure they comply with safety requirements and function without incident in both normal and fault situations. Maintenance and inspection. For the purpose of identifying and resolving electrical safety hazards, medical devices require routine maintenance and inspection. Radiation safety. Here are some key considerations and measures taken to address radiation safety. First, regulatory compliance. High regulatory regulations and recommendations regarding during radiation-based operations should be included in medical devices. The device should also offer shielding or accessory options to protect delicate parts of the body that are not the target of the radiation. NBSP. Safety must be followed by medical devices that emit ionizing radiation. Second, dose optimization. Medical devices should be created to minimize radiation exposure while balancing what is needed for an accurate diagnosis or efficient treatment. Third, quality assurance and calibration. Routine checks and calibrations help avoid underdose or overdose situations, minimizing the risk of misdiagnosis or unnecessary radiation exposure. Fourth, radiation safety interlocks. Interlocking safety mechanisms to ensure adequate patient placement, appropriate shielding, or the use of radiation only when all safety precautions are in place are examples of interlocks. This mesh helps in reducing accidental radiation exposure. Fifth, user training and guidance. Medical professionals should get through user training and guidance materials from manufacturers of radiation-emitting medical devices. This covers details on radiation protection, appropriate usage procedures, and suggestions for reducing radiation exposure to patients and employees. Next, patient positioning and shielding. Features to assist with optimal patient placement during radiation-based operations should be included in medical devices. The device should also offer shielding or accessory options to protect delicate parts of the body that are not the target of the radiation.
Thank you, Azra. My name is Amira, and I will continue this presentation. Chemical safety. The first one is regulatory compliance. Follow regulations and standards set by authorities like the FDA or EMA to manage chemical risks effectively. Secondly, material selection. Choose materials that are biocompatible, non-toxic, and suitable for prolonged contact with human tissues or fluids. In addition to chemical characterization, identify and assess all chemicals used in the device, including those in materials, coatings, adhesives, lubricants, and cleaning agents. Furthermore, risk assessment. Evaluate the potential harm of the chemicals in the device by considering exposure route, duration, toxicity data, and safe limits. Next, manufacturing controls. Implement strict controls, proper handling, and storage of chemicals during manufacturing process. Moreover, labeling and instructions for use. Provide clear labeling and instructions, including proper handling, storage, disposal, and precautions related to chemical exposures. Lastly, post-market surveillance. Continuously monitor and collect data on adverse events and chemical-related issues to evaluate the device's safety and identify emerging risks. Biological safety. Firstly, biocompatibility. Use materials that do not cause adverse reactions or toxicity when in contact with living tissues. Test the device's interaction with biological systems for safety. Following that, sterilization. Properly sterilize devices that come into contact with sterile body parts or fluids to eliminate or inactivate microorganisms. Another point to consider, risk assessment. Identify and evaluate potential biological hazards associated with the device. Consider the intended use, duration of contact, and patient population vulnerability. Equally important is infection control. Minimize the risk of infection with features like smooth surfaces for easy cleaning, antimicrobial coatings, or disposable components. Subsequently, packaging and sterile barriers. Use proper packaging and sterile barriers to protect devices from contamination and maintain sterility during storage and transport. Last but not least, instructions for use. Provide clear instructions on proper handling, cleaning, disinfection, and sterilization procedures to prevent biological risks. Lastly, but most importantly, post-market surveillance. Monitor device performance and safety in clinical use to detect adverse biological reactions or infections and take corrective actions. Now, I will hand it over to Sayakana to continue this presentation.
Thank you, Amira. Hi, I'm Sayakana. There are 4 key points to consider regarding fire and explosive safety in medical devices and instrumentation, which is firstly, regulatory standards. Medical devices and instrumentation are subject to regulatory standards and guidelines that include requirements for fire and explosive safety. These standards ensure that devices are designed, manufactured, and operated with measures in place to minimize fire and explosion hazards. Secondly, electrical safety. Proper electrical safety practices are crucial in preventing electrical malfunctions that can lead to fires. Medical devices should be designed and manufactured to meet electrical safety standards, including insulation, grounding, and protection against electrical faults. Regular maintenance, inspections, and adherence to electrical safety protocols are essential. Thirdly, flammable materials. Some medical devices and instrumentation may contain flammable materials, such as gases, liquids, or chemicals. Proper storage, handling, and disposal of these materials are essential to prevent fire hazards. Adequate ventilation and adherence to safety protocols when using flammable substances are crucial to minimize the risk of fire. Last but not least, heat generation. Some medical devices generate heat during operation, such as laser systems or electrosurgical devices. Adequate heat dissipation mechanisms should be implemented to prevent overheating and minimize the risk of fire. Temperature monitoring and safety features, such as automatic shut-off mechanisms, should be incorporated into devices to prevent excessive heat buildup.
My name is Afifa and I will continue this presentation. The next part is environmental safety. In this part there are having 4 points, which are hazardous materials, waste management, energy efficiency, resource conservation. So we start with the first point, hazardous material. Medical devices may contain dangerous substances like heavy metals, radioactive materials, or chemicals, so proper management and disposal are crucial to protect the environment. Manufacturers should reduce the use of hazardous materials and provide clear instructions for safe handling and disposal. Next, waste management, which is the proper waste management, minimizes the environmental impact of medical devices by separating and disposing of different waste types, such as biohazardous waste, sharps, and chemicals, according to regulations. Healthcare facilities should establish protocols for waste segregation, recycling, and safe disposal to protect the environment. After that, energy efficiency is the medical devices and instruments that should prioritize energy efficiency to reduce their environmental impact. This includes implementing power-saving modes, automatic shutoff, and low-energy components. Healthcare facilities should promote energy-saving practices for operating and maintaining these devices. Then, the resource conservation is the medical device manufacturers that promote environmental safety by conserving resources. This involves using recyclable materials, minimizing packaging waste, and reducing single-use devices. They should prioritize durable designs to minimize replacements.
Thank you, Afifa. Hi, I'm Norziakana. I will continue this presentation Material Safety Data Sheet. Introduction, Material Safety Data Sheets, MSDS. Also known as Safety Data Sheets, SDS, provide important information about the properties, handling, storage, and safety precautions related to hazardous materials used in medical devices and instrumentation. Purpose of Material Safety Data Sheet is to serve as a comprehensive document that provides essential safety information about hazardous materials used in medical devices and instrumentation. It helps healthcare professionals, manufacturers, and users understand the potential hazards associated with these materials and take necessary precautions to ensure safe handling, storage, and disposal. Data sheet of glyphosate at the 27.0% SL region from New Farm Company. Here also example detail contain that needed.
Thank you, Sayakana. Hi, I'm Afifa. I will conclude all of this topic. For conclusion, we can conclude from this topic, which is medical safety, are that ensuring medical safety in medical devices is extremely important. This involves strict quality control, thorough testing, and following regulations. It's vital to monitor and assess risks, promptly report any problems, and collaborate with healthcare professionals and regulators. Advancements in technology and user-friendly design should prioritize safety to improve patient outcomes. By prioritizing medical safety, the medical device industry can build trust, promote public health, and contribute to better healthcare. That's all from us. Thank you.